Hi, I'm Cliff Jacobs from the National Science Foundation. We are at the second charrette, and we have one of their concept awards that's going to tell us what they're up to. So the first question I have is, who are you? And then I'd like to know what group you're part of. And then what have you been working on, and what do you have to show us?
Sure. So my name is Michael Gurnis, and I'm from Caltech, and I'm from the service-based integration platform concept group. I guess in the short way of describing that is the web services concept group. And what I'm going to show you is one of the examples which we've worked on over the last several months to demonstrate what we call the horizontal integration of data using very simple web services. And I'm going to show you a live demo that basically demonstrates a very fundamental feature of the Earth, and that is if you go backwards in time, of course, all of the continents move around, and one of the fundamental ways that we store data and a fundamental concept of EarthCube is to store data in the present-day coordinate system. But if we want to go back and look at older rocks and older features in time, then we must basically create a new frame of reference to look at the data. And so what we have here is a client, and this is a client, a pre-existing client which we have. It's a program called G-Plates, and it's basically a plate tectonic reconstruction engine, and it allows us to go backwards in time. And what you'll see here is you'll see obviously the 50 states here, but then you'll see color-coded are different plate boundaries. These are the tectonic plate boundaries, like over here, right in here, we have the Mid-Atlantic Ridge, and we have the deforming western United States. Now, in this particular example, what we're going to use is the web services to make a very, very simple query of one of the other participants in the concept group, and that is Shannon Peters' concept, his database called MacroStrat. And that's basically a database of sedimentary rocks in the past. And so what we're going to do here is we're going to make a query of web services. And the first thing that we do is let's just zoom in to make things easier, because I'm sure on film it's really quite hard to see. Okay, so here we are, the United States, and it's the present day. You can see up there it's 0 million years. So we're going to make a little polygon right in there. Why don't we make just a small little polygon in the southeast, come across Florida and then up. And so you can see we have a little polygon, and then we're going to just press this button over here, and we're going to make a query. And what comes up on the screen is basically a URL, and that's a URL of his database in Wisconsin. Okay, it's in his lab in the geology department there, and we're going to make a query to extract the data over the last 50 million years. And we have what's called a URL builder, and that's one of the things we do in the concept group. We're talking about building URLs to make these queries. And there's no standardization at all in science. It's very diverse, incredibly heterogeneous, and we want to do this in a very simple way and maybe bring some harmony. So we're just going to press the button, and you can see, it already got them. It recovered 241 features back from Wisconsin, and it does some internal translation inside the program. And then you'll see on the screen here what we have is, unfortunately, they're a little bit light gray, okay? And what we want to do, the first thing we need to do is that this data knows that it's in Florida, in South Carolina, and North Carolina, but it doesn't know where it was back in the Eocene 50 million years ago. So we have to give it that context. And so we need to do some data processing here. That's the first thing we need to do. And that's called assign plate IDs. We're going to basically put it on the North American plate. We have to tell it that. And we have to do a couple little clicks of the mouse here. North American consistent deformation here. Next. And then we also need to work with the data that we just recovered. We just press another button for the data we just recovered, and then there's some default parameters on how to do the mapping, and then voila. Now quickly what you'll see is they all turn green, so it knows it's on North America, and we need to assign colors to the different kinds of rock types, and we'll do that right now. We have to open up a little file that we have on our system that color codes the rock types, and then we get that, and now they're color coded by the rock types. And then the other thing is we'll just fill in these as polygons, and so they're color coded. Okay, so now we did it. We just grabbed the data, and now we've processed it. Now we can put it into the plate tectonic concepts, and we can rotate. Why don't we rotate them back to 50 million years ago very quickly? And there they are. There's a few things that you see on North America. The deforming region has gone away, and now we have different rock types. The most vivid one actually is in dark blue is actually our carbonate rocks. And then what we'll do is we'll just press the button and we'll process that. In North America we'll move towards the west, and you'll see the occurrence of the different rock types as the different inland seas came off and they inundated the southeastern part of the United States during this period of time. So that's what we have to show so far. We've been able to demonstrate some very simple examples of using simple web services, Clef.
Thanks a lot, Mike. That was an interesting demonstration.